Hello everybody, today in Science, Technology and History we are taking a trip back history lane and math and to visit Pythagoras' worst nightmare. So what is it all about? Let's get started. So Pythagoras, he was born in the 570 BC and lived until 495 BC. He was born in the island of Samos, but he was active in the Magna Graecia, the Greek city-states and colonies in Italy. And he was really a famous mathematician and scientist of that time. He's most known for the Pythagorean theorem for a right-angled triangle. He formulated that a squared plus b squared equals c squared, and he also found this very beautiful triangle 3, 4, and 5. It's a very nice and fitted really nice into Pythagoras' theory of the world. So the Pythagoras and Pythagoreans, they really believed in a beautiful cosmos arranged with math and nice ordered harmony and rational numbers, integers, and everything played in a higher state of harmony. For example, he found the tetractys. If you add the first four numbers, 1 plus 2 plus 3 plus 4, you get 10, and it's also a nice triangular shape. He believed in the symmetry of the cosmos and the spheres of the planets, and he imagined that they played some harmonies and the ratios between the planets were very orderly. And he also found he was really active in music, focusing on the harmonies. He realized that if you have strings with integer ratios, they create nice harmonies. For example, an open string, and then if you put it in half or three seconds or 4/3, you get nice and beautiful symphony. And the idea of the Pythagoreans and Pythagoras was that all numbers must be rational. Rational numbers means either integers like the ones 1, 2, 5, 10, etc., or function or fractions of integers, for example, 3/4, 5/8, 22/7. So everything he believed in the world could be expressed with integers or fractions of integers. But it turns out nature has some tricks up her sleeve, and nature is actually very cruel if you are a Pythagorean trying to make sense of everything in rational numbers. Because if we imagine even the simplest geometrical forms, for example, a square with side 1 or a circle with diameter 1, some hidden in plain sight, we have some numerical monstrosities if you are Pythagoras. So in the simplest square, how long is the diagonal here? And for the circle, what is the circumference? So poor Pythagoras, for his students and himself, was trying to find how to express the diagonal in such a square, and the Pythagorean theorem shows us that this will be the square root of 2. And legend states that one of the Pythagorean students, he discovered that this cannot be described with rational numbers, and the legend states that he was drowned or murdered by the fellow members for revealing this secret. This is debated, of course, and they were struggling to make ration about this diagonal. Euclid, around 300 BC, he made a very elegant proof that square root of 2 cannot be a rational number. This means that irrational numbers exist, and they exist in the simplest forms in cosmos. So Euclid's proof is very beautiful. I will not go into detail here, but he could reason that if square root of 2 really indeed was a rational number, so it could be expressed like a fraction of two integers, he could conclude that they both were even, and then he could perpetually simplify this, and this is not possible forever. So therefore he could prove that square root of 2 is not a rational number, shaking the Pythagoreans to their core. So of course today we know irrational numbers exist. We know that square root of 2 is irrational. Here is the first 50 decimals, and the irrational numbers, they have a decimal expansion that never ends and never enters a repeating pattern, unlike rational numbers, but they are real numbers. They are part of the real number system and exist between any two rational numbers. And now this doesn't shake us, but I think Pythagoras would be his worst nightmare, the square root of 2. And also Probably a hope for Pythagoras' sanity that he didn't investigate a lot of the circle. The circle, of course, the circumference is pi, or p as we say in Greece. So again, millions of decimals. I find that also extra salty for Pythagoras, that his name starts with a P in Greek. This is how you spell Pythagoras here. So how simplicity of the smallest, of the simplest the geometry includes these irrational numbers. The final insult, the coup de grace, the last straw, I think for me, is the devil's tritone. So Pythagoras, as we said, was really interested in the harmonies of strings, and the tritone is the interval of three whole tones, and this is very dissonance-like, and splitting the octave in half. And this sounds, it gives some evil tone to the music, and actually it's very close to a square root of 2 to 1. So basically this the square root of 2 is the devil's tone in music, and it's actually used extensively in heavy metal and rock music to create the tension and darkness. It's called diabolus in musica. So I'm happy I like death metal and rock, but it's interesting that the square root of 2 also haunted music for Pythagoras. So this concludes the video. I hope you enjoyed this bit trip back in memory lane and in history of Pythagoras, numbers and science. I really sympathize with Pythagoras and the Pythagoreans, that they try to make sense of our world around us and try to see the beauty and the and everything with integers. But nature is much more complex and has the last laugh, and it's maybe even more beautiful with these irrational numbers. But poor Pythagoras, but he was at least at the forefront of these mathematic discoveries. So this concludes the video. Let me know what you think, and please press like and subscribe for similar videos about science, technology, and with mix with history. So with these words, we're signing out. Stay safe out there, and bye bye.